Okay, so this is a video following on from some of the previous videos I've done recently on naming organic molecules, specifically naming alkanes and alkenes. This is really to give you students a good insight into naming of these molecules, which will then be a common thread that will run through the entire specification of AS and A2 chemistry. Today here we're going to deal with drawing molecules and converting formulas that we've already done into skeletal formulas. So we've got molecular formulas, displayed formulas, names, and we're going to convert those into what we call a skeletal formula. We're going to start off with alkanes and alkenes, and I'm going to do a few at the end, which are some functional groups which perhaps we haven't met yet at AS chemistry, but you should, by the time we get to them, be able to turn the names or turn the structures that are on the board into skeletal formulas quite easy, even though they are unfamiliar to you. So let's get going. So the first thing I suppose we should ask ourselves is, what is skeletal formula? Well, skeletal formula is essentially a very shorthand diagrammatical formula used by chemists, and it omits all of the carbon atoms and all of the hydrogen atoms that are attached directly to carbon atoms. So that's a really important part. Okay, so it makes life very easy for us as chemists and for you as students. Whenever we're drawing long convoluted molecules, we can leave out all of the carbons and we can leave out any hydrogen that's directly bonded to them. So some of these will look a bit strange, okay, but hopefully by the time I work through a few, you will be able to see, and be able to see where the formulas are coming from, and you'll be able to turn names and structures into skeletal formulas, and you'll be able to turn skeletal formulas back into names and structures. So let's take the first one here. So what I said was, and this is really important, we leave out all the carbons and we leave out any hydrogens that are bonded directly to them. So if we look at this, we have 3 carbons in a row. So what we do is we go 1, 2, 3. Every time we have an end of a line or an angle, that tells me that there's a carbon there. So in other words, 1, 2, 3 means 1, 2, 3. Okay, now I've got to remember that I have still got this carbon here. How do I represent that? Well, I just do a line, and that tells me that there's a carbon there, a carbon there, a carbon there, and a carbon there. Now you might go, well, how do you know how many hydrogens are attached to those carbons? Well, you count the number of lines or bonds that are on each of the carbons, and anything that is not there must be a hydrogen, because remember, the only thing we don't draw in are hydrogens that are bonded directly. So if we look at this carbon here, there must be 3 hydrogens because there's already 1 bond on it. If we look at this one, the same is true. If we look at this one, the same is true, 3 hydrogens. If we look at the one in the middle, there's only there's 3 lines or 3 bonds on it already, so therefore there must only be 1 hydrogen. And if you cross-reference those 2 structures with each other, you will see that they are exactly the same. So therefore, if I was drawing this as methyl propane, all I would do is that represents methyl propane in skeletal formula. If we took this molecule again, like we always do, we find the longest chain. So we've got 4. So we go 1, 2. We go 1, 2, 3, 4. So there we go. You can see 2 ends and 2 angles. So we've got 4 carbons. We've got this group here, which is in the second carbon. Very simply, just a line. Okay. So just to explain quickly again, I'm not going to do this for all of them, but I'll do it for the first few, just so you get the gist. We have our 5 carbons, 4 in a straight line. Okay, that one only has 1 line on it, so it's missing 3 hydrogens. This one has 3 lines on it already, so it's missing 1 hydrogen. This one has 2 lines on it, so it's missing 2 hydrogens. This one has 1 line on it, so it's missing 3, and like so. So if you correlate that or reference that to that structure, you'll see it's exactly the same. This one here, then a little bit longer, but again, hopefully we're now starting to get the picture. So in our longest chain, we have 1, 2, 3, 4, we have 7. So very simply, we start 1, 2, 3, 4, 5, 6, 7. We go to our 1, 2, 3, 4th carbon. So 1, 2, 3, 4, this carbon here, we have an ethyl group. So all we do is we go angle line. And that represents exactly what we have on the board. Probably a good idea now that you've got the gist of these, that you start pausing the video whenever I bring them up on the screen, do them and then double check them against my work. Okay, this one here, again we have 7 carbons in our longest chain, so we go 1, 2, 3, 4, 5, 6, 7. We go to the 4th carbon along and we have a methyl group, so 1, 2, 3, 4, methyl group. We go to the next one along, and we have an ethyl group, 2 carbons. Job done. Next one, we have 1, 2, 3, 4. We have 8 carbons, so we go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, just checking. Okay, we go to the 3rd carbon, we've got a methyl group. It's very simple. We go to the 5th carbon, we have a propyl group this time, so we go 1, 2, 3. There we go, that's our answer. This one, we have got 7 carbons, so we're hept 1, 2, 3, 4, 5, 6, 7. We have a dimethyl on the 3rd, so we can just go line, line. Okay, and we have another methyl on the 5th. That's the answer to that one. This one, we have 4, 1, 2, 3, 4. We have 2 methyls on the 3rd, or the 2nd, is it? Sorry, I should number from that side, not. Okay. This one, very simple, 3 carbons, 1, 2. Okay, we have 2. Okay, on the 2nd, 2 methyl groups in the 2nd. That's it. This one we have 5, 1, 2, 3, 4, 5. We have 2 ethyl groups, okay, which we need to deal with on the 3rd. So we go 1, 2, and we go 1, 2. There we go. That's our compound, exactly the same as above. Okay, this one is, let's see, 2, 4, 6, 8, 10. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have a methyl group on number 5, so locate number 5, 2, 3, 4, 5. Methyl group there. We also have an ethyl group on the same one, okay. So we go, oh, sorry. We go, oh, dear me. 1, 2, okay. This one here we have 1, 2, 3, 4, 5, 6, 7, 9 in our longest chain. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we go to 4 in this direction. We have a methyl. So 1, 2, 3, 4. Methyl, very simple. We go 2 more along. We have an ethyl. Job done. Very simple. Okay, let's look at ones with double bonds. These are not really much more difficult, to be quite honest with you. We've got 4 in our longest chain here. So we go 1, 2, 3, 4. We have a double bond, remember, on number 2. So all we do there is as so. We have a methyl group on 2, and we have a methyl group on 3. Okay. So again, hopefully you can see fairly easily why that is as it is. Right, this one we've got 5, 1, 2, 3, 4, 5. Okay, we have a double bond on 2 this time, so we bring our double bond down between 2 and 3. We have a methyl group on 2, we have a methyl group on 4. Very simple. This one we have 4, 5 in our longest chain again. Okay, we have a double bond there. We have methyl group there, we have ethyl group here, and we have a methyl group there. Okay, this one we have 5 again. Okay, we have a double bond between 2 and 3, so we do our double bond there. Okay, we have an ethyl group on 3, so we go. Okay, and we have a methyl group on 4. Okay. This one we have 5, 1, 2, 3, 4, 5. Again, double bonds on 1 this time. We have 3 has a methyl and 4 has a dimethyl. There we go. We have 4, so it's a bute. We have a bute with a 1, or a double bond on 1, sorry. And we have a dimethyl. So there we go. This one, we have our longest chain is 1, 2, 3, 4, 5, 6. So it's a hex, 1, 2, 3, 4, 5, 6. Double bond on 1. Okay. Methyl group on 2. Ethyl group on 3. Methyl group, sorry, on 5. There we go. That's not right. I've done something wrong. I would have done wrong. Let's redo that one. 1, 2, 3, 6. 1, 2, 3, 4, 5, 6. Let's see. Double bond is on 1 for sure. Yeah. Oh yeah. I put this on the wrong carbon by mistake. Throw me off. So I have a methyl group there, and then on 1, 2, 3, I have an ethyl group, Okay, and then on 5, I have a methyl group on 4. Sorry, not on 5. That's it now. Okay, that's wrong. Ignore that. Okay, so we've got 7. 1, 2, 3, 4, 5, 6, 7. We have a double bond on 1, 2, 3. So 1, 2, 3. Double bond here. Oops, a bit wobbly, but you get the picture. Okay, our second one has got dimethyl. Our third one has got methyl. Okay. That's not the third one. Third one has methyl. Fourth one has nothing, and then we have a diethyl here. So we have a diethyl on number 1, 2, 3, 4, 5. Yep. Right, let's look at ones with more than one double bond in them then. So again, we've got longest chain of 1, 2, 3, 4, 5, 6. So we go hex 1, 3, 4, 5, 6. We have a double bond on between 2 and 3. So let's put a double bond between 2 and 3 there. And we have a double bond between 4 and 5. We have methyl groups. So these are not methyls here, remember, these are just the ends of the chain. We have methyl group there. And we have methyl group there. That's that one done. Okay, here we have a butadiene. So we've got 1, 2, 3, 4. Okay, we have a double bond there. And we have a double bond, yes, between 1, 2. And that's all I would do there. There's no alkyl groups to deal with there. Okay, this one, let's see, we've got 1, 2, 3, 4, 5, 6, 7. So I have a 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, yeah. I have a double bond between 2 and 3, so let's do that. And I have a double bond over here between 1 and 2, it is actually. I have a methyl group on number 2. That's the answer. Right, let's go into amines now. I did say earlier, if you remember, that we don't draw a hydrogen directly attached to carbons. So let's deal with this part of the molecule first. It's 3, 1, 2, 3. Okay, now, then we go to the nitrogen, okay, which is attached to 2 hydrogens. So those hydrogens are not directly bonded to carbons, so they are drawn in. It used to confuse me whenever I was a student. I used to think, oh, is there a carbon here? There isn't. When we go to a functional group, there's a line drawn to that functional group, even if it's a subordinate group. Okay, so for example, a chloro or a fluoro. So the last carbon in the chain is this carbon here. Okay, same again here. I have 1, 2, 3 carbons. I have to draw my oxygen to my double bond. And then I have to draw my oxygen to here, which is attached to a hydrogen. So I draw this hydrogen in because it's not directly bonded to a carbon. Okay. So there is a carbon here this time. Okay. This one here, we have 5, 1, 2, 3, 4, 5. Again, double bond. Okay. Single bond O, single bond hydrogen. We draw the hydrogen in because it's not attached to a carbon. Okay, we have nitriles then, which we haven't done yet. So we have, how many? We've got 6. 1, 2, 3, 4, 5, 6. Okay. We have a carbon at the end. Okay. We don't draw it in, but we draw the nitrogen that it is triple bonded to. Okay, that's a compound called hexane nitrile. You won't meet it, okay, until quite a bit later in the course, okay, towards the end of the organic chemistry. But it's called hexane nitrile. Note that the E is there, it's not hexane nitrile, hexane nitrile. Alcohols then, very simple. Okay, here we have, okay, going to an O, H. And again, there's only 2 carbons. Those are the 2 carbons in the bond. The line goes to the functional group. Okay, here we have 5 alcohol. 1, 2, 3, 4, 5. We do the same thing again, line to the functional group. Oh no, don't, because that functional group is not at the end. Apologies. Okay, it's on number 2 here, so we go O, H, like so. Okay, here we have an alcohol with a methyl in it, so we've got 1, 2, 3, 4. Okay, we have an OH, it is on the end this time. Okay, and then on carbon number 2, we have a methyl group. Very simple. Okay, so that's as many as I'm going to do, guys. Hopefully, I've pretty much covered all bases there. You can go back, pause the video, have a go at those, all the answers, and check the answers as you go along. I think if you can do those ones, you should be fine in terms of the ones that you get in A-level chemistry. All you'll have to do is apply the rules that I've taught you there. And if you can apply those rules, which you should be able to, I don't think it's that difficult, you'll be fine. Okay, hope that helps. Any questions or queries, just contact me in class.